So I'm here with something unusual today. I have a couple of interesting PCIe cards. So if you've been following my channel for a while, you know that I've been working a lot on various MIPS-based Wi-Fi routers, and gave a talk at the International Plan 9 workshop on my efforts on updating the MIPS system for 9 front. Anyway, so on some Discord, hanging out with some other Plan 9 and 9 front people, someone posted about these and mentioned, hey, have you thought about working on them at all, since you know something about MIPS? What these are data processing units. They're basically a computer on a PCIe card with some high-end networking stuff, and you put them in a server and they can sort of do some extra work on the networking traffic for you. Both these chips were made by a company called Cavium. They got bought up a while back, so finding information on these is getting a bit difficult. And these are both Octeon 2 processors. This big board here is a 24-core chip, and this one over here is an 8-core. The small one has 2 gigs of RAM soldered right onto the board and a little flash module on the back. And the big one here, I don't think it has flash. It might have some small amount on here somewhere. But it does have 8 gigs of DDR3 ECC RAM here, these mini DIMMs, 4 gigs each, so it's 8 total. So yeah, interesting bit of kit. So initial things I noticed, I haven't really played with this one much yet. I did pop off the heatsink and clean it up a bit. Did that with the other one too, because these are actually pretty old, like about 10 years old or so, and the thermal paste is getting a little dried out. So mostly been playing with this little one because most of my little test systems I have around are those little, half height, small form factor Dells, and this is a half height card. I can pull the bracket off and it'll slot right in. And they definitely are meant to run in a server environment because the heatsink on them isn't that big, and these things get really hot real fast. So you definitely got to get a lot of airflow over them to keep them in a reasonable temperature. But I bought them a few months back. Tried getting into them, especially this one, and it was really difficult. I did find some information on some people who ended up supposedly porting OpenWRT to these things. So you could put it in your computer and have it run as its own separate self-contained router for your network. And they did have some useful information along with the SDK from Cavium, which came with a version of U-Boot all patched up to work with these. So I'm going to go ahead and plug this in and fire it up and show you what that looks like. First off, though, I'll show some of the bits of information I did find. So there's some PDFs floating around out there, these sort of little product briefs. So this is sort of that bigger board there. It's the chip in it is the cn6870, and according to the numbers on the chip, it runs at about 1 gigahertz. So that's 24 cores, according to the information down here. So it does have a listing for that particular model, says it's 24 cores, and has a few other things. So these are meant to do a lot of sort of offloading of stuff here. So let's zoom this in. Sort of show like the sort of stuff it has on here. So yeah, you have a bunch of cores, the networking stuff going in and out, and it doesn't have all the information on here, but going through the SDK, these things can do all kinds of stuff for encrypting and decrypting. Matter of fact, these particular ones don't have a floating point unit. Like some of those little router boards I work on will have no floating point unit, but they'll have a digital signal processor for processing audio or something for use in phones and things like that. These ones will have stuff that's like, meant to do encryption and decryption, and various file sort of stuff. So yeah, here it has special accelerators just for, zip and unzip. All kinds of strange stuff in here. Part of the reason these were made, I mean, we take it for granted nowadays that, like, 10 gigabits is not that big of a deal. But, these things were, I think they have the date up here. Yeah, this is considered pretty awesome back in 2011, this whole idea. Back then, like, getting your computers to actually intake, multiple 10 gigabit TCP, streams was asking a lot. And what these things would sort of do is, strip some of that down, sort it for you, and then send it off to the actual server it was plugged into. So, the other small one I have is closer to this. It's a 6640. This little brief is for a couple other variants, and I mentioned some of the fancy stuff it does. Let's see here. Yeah, you can see this is back when, PCIe Gen 2 was a thing and DDR3 was a thing. And so it gives you some idea of like how you can, use it to basically take some load off your servers. And the actual card I have, that little one, is technically one of these. And if you plug it into a Linux system, it will sort of detect it and try to use it as a glorified 10 gigabit Ethernet card. Currently, from what I've heard, some of these don't actually work. A lot of these small ones came out of Amazon data centers, and they're configured differently. So even though Linux will try to load the like a firmware into it, it'll just fail. So yeah, you can see this is sort of like that little card I had there. And yeah, it's just for, processing traffic for you to take some load off the server itself. But these ones, it actually doesn't even mention that they are just a full-on MIPS-based computer. It just gives you information on it like it's just a fancy networking card. And if they actually do, if you load the firmware onto it from Linux, Linux will just treat it as an Ethernet card. It just sees it as a couple Ethernet ports. But really what it's doing is it's loading like a trimmed down Linux operating system onto the card to do a bunch of processing for you. So it just looks like an Ethernet card that does a bunch of fancy stuff. But really, it's a full-on, computer, a 64-bit multi-core computer with gigs of RAM. So I'll go ahead and get this little Dell box fired up and show you how I could get into it. So hopefully my audio is coming through okay. I had to turn the noise suppression up full blast because, like I said, this thing needs quite a bit of cooling. So the little Dell box I have, set it to just run the fans full blast. So it's humming away pretty loud in the room here. So I did find some instructions on how to mess with these from a couple of guys porting OpenWRT to it. And they'd gotten their hands on the SDK and posted it up on GitHub. I'll put links to all this down in the description. Went through that and found the basic instructions. So I had these things a couple months ago and I tried it and it just was not working. And so I put it on a shelf and was doing other stuff. And a couple nights ago, the whole thing came back to me and I decided to dig into it and see why it was giving me an error. And in the end, it turned out that, I'm not sure exactly who to blame, but running these commands as a regular user wasn't going to work. Running them as sudo wouldn't work. I had to actually get a full root console. So tried that, and sure enough. So when these things are plugged in, it can be talked through the PCI bus like any other card you'd put in, and you basically have access to the memory on it. The SDK comes with a bunch of tools to allow you to just inject stuff into the card's memory and have it run it. So And along with those sort of tools was U-Boot with most of the drivers and stuff for these cards already put in. And so I went through it. I built a version of U-Boot for this specific card, which is called the Octeon SNIC 10E. And so I'm going to use this command oct remote boot to inject it and an environment file, which has some environmental variables. One of those is it's going to tell it to not do any sort of countdown and boot into anything else, like a lot of U-Boots tend to do. The other thing that it'll have is specifying consoles. So a lot of these cards do have UART pins hidden on them somewhere. Another feature they have is that they can run sort of a virtual UART through the PCI bus. And that's how I'm actually going to talk to it. So I set it in there saying, hey, turn on the PCI console as an option. So I'll take this command, put it over here, and run it. And we can see it found it and wrote to the address and exited out. And now I'll run this command here to actually talk to the console. And here we are. So something I've run into right away is that right off the bat, the Ethernet isn't working. And I'm not exactly sure. Looking around, there's a lot of notes on how these things have really quirky networking interfaces. And when you're dealing with SFPs, they have their own built-in configuration, and it could be them. Like I said, it does run hot, and with the version of U-Boot here, they threw in some extra fun commands, so I can bring up the temperature on it. There is a tool to read the SFPs. Let's see, info through I2C. So in this case here, it can see them. I have just a little copper wire job plugged in there right now. But if I use the command provided for the Octeon specifically to read it, let's see, the oct eth0. Yeah. So it doesn't see it. If I tried the other port, it still doesn't see it. So for now, I don't have any direct access to the network, but it is running U-Boot, and it is running some interesting specific commands for this little board here. So this one here, if you mess with enough MIPS systems, you realize these are the standard registers for coprocessor 0 on a MIPS system. So we have the config registers. These ones here are for the TLB stuff. There's count, a bunch of other things, some debug registers, cause, things like that. So this is accessing it. So not a whole lot I can pull out. There is quite a few commands. I could poke a bit more stuff. But yeah. So it is a start. If I can load U-Boot and get it to boot, it would be possible to do something like 9-front. So people have already been asking me 9-front on a networking card when. We'll see. There's already some MIPS 64 code in the Legacy 9 branch left over from an effort to port Plan 9 to old Luang Sun chips, which the original Luang Suns were just standard MIPS. So the evolution of those ones was it was MIPS, and then they added some stuff, and they gave it some other name, and then to just sort of get out from the whole licensing thing, they came up with Luang Arch, which looks like MIPS with a bunch of heavy changes. Like I think they finally got rid of delay slots and some stuff like that, and of course started adding new, SMID instructions and things like that. But yeah, so this is what it looks like to get inside a full-on computer on a PCI card. See if there's any other interesting stuff. MTD parts I can read. So this thing has like some flash on it, and of course it also has like a bit of like NAND or NOR, like an itty-bitty flash thing like a lot of embedded systems have. So yeah, it does. It sees bootloaders, environment, some other stuff. Active partitions, yeah, NOR. So there's a little itty bit of flash on there that U-Boot could read to boot up from. But yeah, so sort of a bit of, you know, odd hardware floating around out there. These things can be found on eBay for fairly cheap. Prices kind of fluctuate. You know, servers, server farms are always upgrading. These ones here, I think, are around 10 or so years old. Most of the notes seem to be, a lot of them came out of Amazon. But there's a variety of ones out there. There's some development boards. A few router companies use these chips. So there are some kernels out there for, like, you know, Linux, obviously. OpenWRT, OpenBSD has some. But yeah, sort of an interesting bit. You can also find some newer stuff, but these things don't tend to be cheap brand new. They are considered like, you know, professional server grade equipment, and you pay those kind of prices for them. But anyway, as usual, have fun.